Welcome back, everyone. Today we're going deep on a research paper that Curt Robbins, our senior technical writer, suggested.
Yeah, this is going to be good.
It's called The Cultural Evolution of Technology, Facts and Theories.
Okay.
And it's by Robert Boyd, Peter Richerson, and Joseph Henrich. It's all about how humans, we adapt and survive in all these different environments,
Yeah,
right?
yeah.
And tools, how tools play a part.
Yeah, it's amazing, isn't it? How we can just create, use tools, and boom, we're thriving in the desert, the Arctic, underwater, you name it.
It really is. And this paper, it really digs into that, like the collective intelligence.
Yeah, we always talk about individual inventors, those brilliant minds, but this paper really emphasizes that it's more than that. It's like this collective thing,
Okay.
over generations.
Yeah. And it's like you take, for example, the Central Inuit people
Yeah?
living in the Arctic. I mean, they've got like the caribou skin clothing, the snow houses, the tools they use for
Okay,
hunting.
yeah, the harpoons and all those specialized tools.
It's like a whole system perfectly designed for like one of the harshest places on Earth.
It is. It makes you think, could you just, drop someone into the Arctic
Right.
with no knowledge and expect them to survive?
No way.
Not a chance. History's full of examples of that not working out so well.
Oh, yeah, totally.
Like the Franklin expedition.
Right?
Even experienced European explorers, they couldn't survive without that knowledge, that accumulated, culturally evolved knowledge.
They were missing that cultural like backbone.
Exactly. Like the
Yeah.
Inuit weren't just, poof, born knowing how to build a kayak or hunt a seal.
Oh, yeah.
It's generations, centuries even, of passing down, refining those skills.
Okay, so it's not just about those like light bulb moments.
Eureka moment.
Yeah, those eureka moments.
Not really. This paper really stresses that it's gradual evolution. Like most advancements, they're really just small changes, right?
Small incremental changes.
Yes. Accumulated over a long time.
So it's like, if I'm picturing this right, it's like standing on the shoulders of like tons of inventors who came before.
Exactly. Like each generation, they inherit this knowledge, right?
Yeah.
Make a few tweaks, maybe a little improvement here or there, and pass it on. The paper uses the example of the North American axe.
Ooh, yeah. I'm interested to hear about that.
Yeah, so it started with a European design. Pretty basic, right? Small head, kind of rounded.
Okay.
But American blacksmiths, over time, they started making these tiny changes, like bigger head, flatter surface. They changed the angle,
Yeah.
and it became the American felling axe. Way more efficient. Chopping, hammering, you name it. And this happened, get this, over like a century.
Wow.
Each blacksmith building on what came before.
So those tweaks weren't so tiny after all.
They add up. It's like deep understanding, efficiency, all born out of generations of trial and error.
It's almost like cultural natural selection.
Yeah, that's a great way to put it. And it gets even more complex. The paper talks about shiprudders. From basic steering oars to those complex stern post rudders.
The ones we see today.
Exactly. 500 years, they say, of little improvements to get to that optimal design.
So this whole idea of innovation, I'm seeing it in a new light now. But I got to ask, this whole cultural evolution thing, isn't that unique to us?
Ah, that's where it gets really interesting. The paper challenges that assumption.
Really? So are we talking chimps using sticks to fish for termites? I mean, that's pretty impressive.
Chimps are cool, but think even smaller. The village weaver bird
Okay.
builds his incredibly intricate nests, multiple chambers all woven together perfectly.
I've seen those. They look like little hanging baskets.
Exactly. And the thing is, they don't learn it socially.
Yeah.
It's instinct. It's like an algorithm passed down genetically.
So you don't need like big brains or social learning to have complex technology. It's mind-blowing.
Right. And it goes even further. Termites, building those mounds, spiders and their webs, even amoebas, single-celled organisms, create tiny houses out of sand grains.
Wow, I never...
Complexity doesn't always equal human ingenuity.
Okay, my mind is officially blown.
Yeah.
So if this cultural evolution is happening everywhere, what makes us, humans, so special?
It's the speed. Human cultural evolution is just, boom, so much faster than genetic evolution.
Yeah, like think about it. In the 20th century, we went from no electricity to smartphones.
In the blink of an eye, practically.
Right. And lactose tolerance, that took thousands of years to spread.
Exactly. And that difference, that speed, that's what lets us adapt and innovate so quickly. But the question is how? How does it spread so fast?
Right. It's not just because we're smart, right?
Right.
What does the paper say?
Well, one idea is cognitive biases or attractors.
Oh, okay. It sounds complicated.
Not really. Think about it. We like patterns, right? Even if it's random data, we'll see lines, curves, trying to make sense of it.
I guess so, yeah.
That bias towards simplicity, it affects how knowledge is passed down. Certain traits become dominant. Maybe not even the best solution, but the simplest.
So our brains like to take shortcuts, and those shortcuts shape what we learn and teach.
Exactly. But it's not that straightforward. The paper also says there's huge diversity in tools and techniques across cultures.
That's true.
Can't be just a few universal biases, right?
Yeah, if it were just biases, wouldn't we see the same tools everywhere?
Exactly. Think of the Plains Indian bow. Super complex, perfect for hunting on horseback.
Right.
That level of adaptation, it points to something deeper, more than just simple bias.
So it's not just about copying what we see, it's learning. It's cultural transmission and the challenges of our environment, all mixed together.
You got it. And that brings us to the big question, the core of the paper. How do these complex cultural adaptations happen? How do they improve when they're built on, like, generations of knowledge?
It really makes you think about how we got to where we are today.
Yeah, and how those hidden mechanisms, they're shaping everything. The tools we use, even the beliefs we hold.
Let's dive into those mechanisms. This is fascinating.
Okay, let's start with an interesting idea. Individual learning, even if it's rare, can have a huge impact on a whole population. So the paper, it talks about this model by Alan Rodgers, and in this model, you've got a population, and individuals, they can either learn something new, which takes effort, or they can just copy someone else.
Okay, so there's a cost to learning new stuff, like a cost-benefit analysis for culture, basically.
Right. You're weighing the effort of figuring it out yourself versus, like, just copying someone who already knows.
Makes sense.
And as long as the new thing, the behavior, is worth the cost, you get this mix of learning and imitating in the population.
So even if it's just a few individuals who are innovating, those new discoveries, they kind of trickle out through everyone else.
Exactly. Gradual improvement over time.
But doesn't that create a problem? Like, what if everyone just focuses on imitating? Where do the new ideas come from?
You've hit the nail on the head. That's Rodgers' paradox. Too much copying and innovation stalls.
Yeah, it's like a cultural dead end.
So the paper suggests a couple of ways out of that paradox.
Okay, how do we avoid getting stuck?
One way is population structure. Like, imagine groups that are kind of isolated, but they still have some contact. Innovations can spread within those groups, and then maybe later get shared with others.
So it's like little pockets of experimentation. And then those good ideas get shared with the wider world.
Exactly. It promotes diversity, resilience.
And what's the other solution?
Selective learning. We're not just mindless copycats. We're pretty good at figuring out who to learn from.
Oh, yeah, we look up to certain people, like the experts.
Right. The paper talks about Fijian food taboos. Pregnant women, they avoid certain reef fish.
Interesting.
Turns out, those fish have toxins. Bad for pregnancy.
Wow. So they knew about marine biology.
No, that's the cool part. Often, they don't know the science behind it.
Huh?
They just learn from the older women, the respected ones, relying on experience, wisdom.
So it's like a cultural safety net, passed down without needing all the scientific details.
Exactly. And that leads to payoff bias transmission.
Payoff biased. So like focusing on what works, even if you don't know why.
Yep. Imitating successful people, even if you don't understand the reasons.
Like following a recipe without knowing the chemistry, as long as the cake tastes good.
That's it. Maybe not the fastest way to innovate, but it's powerful. This explains how some practices, techniques, they refine over time, even without scientific knowledge.
Okay, so we've got slow diffusion from individual learning, then this copying of success. What's the third mechanism?
This one's a bit more obvious from an economic standpoint. It's when innovations spread quickly because their benefits are clear.
Ah, so now we're talking about those eureka moments. Someone invents something awesome and everyone's like, I need that.
Exactly. Driven by rational actors, like the printing press, the steam engine, revolutionary with immediate benefits, so they spread like wildfire.
But that doesn't always happen, right? Especially with those more subtle cultural adaptations like the food taboos.
You're right. The paper says this rational model, it doesn't explain everything. A lot of cultural stuff, especially traditions, social norms, they might spread through those other mechanisms, even if the benefits aren't immediately obvious.
So it's a mix, right? Bursts of genius, copying what works, and then that slow accumulation of knowledge over generations.
It's a beautiful, messy process.
It makes you really appreciate the complexity of it all.
And there's one more big piece to the puzzle, population size, how many people are involved. That actually affects how complex and diverse a culture's tools and tech become.
Oh, I didn't think about that. So, like, more people equals more innovation.
It's not quite that simple, but it's related. The paper talks about cultural drift. Imagine a small, isolated population. Knowledge is passed down orally, right? If the one person who knows how to build a certain type of canoe dies, that knowledge is gone.
Poof, just like that. It's like a game of telephone, but with culture.
Yeah, and in smaller groups, those innovations are more likely to just disappear. Random chance leads to a simpler toolkit, even if those lost technologies were useful.
It makes you wonder how much knowledge has been lost throughout history, just because the right people weren't around to pass it on.
It's a big question for anthropologists. The paper mentions the Tasmanians. They lived on an island, isolated from Australia for a long time.
Oh yeah, I've heard of them. They had a pretty simple toolkit, right, compared to other Aboriginal groups.
Exactly. And that's the point. Isolated from that larger cultural network, their tools became simpler, maybe because of this cultural drift. Shows you how important connection is for keeping knowledge alive, for moving forward.
So being part of a bigger network, it's like a safety net for culture. Protects knowledge, helps new ideas spread.
Right. The paper mentions research by Klein and Boyd. They found a link between population size and tool complexity in Oceania. Bigger islands, more interconnected, they had more diverse tools and techniques.
So it's not just about individual smarts or even how those ideas spread. The size of the group matters too.
It's all connected. It's this web of factors influencing how cultures evolve. But even with all we've learned, there are still mysteries.
Oh, like what? What are researchers still puzzled about?
One of the big ones is heritability. In cultural evolution, I mean. We know that cultural traits, like technology, they stick around, sometimes for generations. But how? How does that information get preserved, transmitted so accurately at a population level? We don't really know.
It's like we can see the results. Different cultures, they have their own traditions, their own technologies. Like there's a blueprint, but we haven't found the cultural DNA yet.
Yeah, exactly. Is it just really careful copying? Or are there other forces at play? Do we have this tendency to just go along with the crowd, even when the crowd's wrong?
That's a good question. How much of what we learn is actually conscious, deliberate, and how much is just like automatic, subconscious?
Right. And that leads to another big question the paper brings up, the role of understanding. We talked about copying success, but how much do people really need to understand why things work? For those technologies to evolve and get better, I mean.
It's like, how many people really understand how their smartphone works or their car, but we still use them? We even contribute to their development.
Right. On the one hand, you'd think deep understanding is crucial for innovation. But then we've got those Fijian food taboos. Sometimes effective practices, they just emerge, spread through observation, social learning, no deep scientific knowledge required.
So maybe it's a spectrum.
Yeah.
Some innovations need that spark of genius, the deep knowledge, while others, they kind of bubble up through trial and error, spread through social networks.
That's a good possibility.
Yeah.
And it probably depends on the technology itself, how complex it is, and the environment, what challenges it needs to solve. Lots to explore there.
This whole deep dive has really changed how I think about technology. It's not just about individual inventors. It's this whole dynamic process. Culture, environment, even a little bit of luck, all playing a part.
I agree. It shows the power of collective intelligence, how we as humans, we've used this cultural evolution to not just survive, but thrive in all kinds of environments.
I'm definitely going to look at the tools I use every day a little differently now, thinking about all the history, all the people who came before who made this possible.
It's amazing, isn't it?
It is. And hey, maybe I'll even come up with my own innovation someday, even if it's just a better way to organize my desk.
You never know. But even if you don't, the important thing is to keep that curiosity going. Keep exploring. The world of human culture, technology, it's always changing, always fascinating.
Well said. And big thanks to Curt Robbins for pointing us to this paper by Robert Boyd, Peter Richerson, and Joseph Henrich. It was a great read. That's all for this deep dive, everyone. Until next time, keep those minds curious.